Okay, so here's online office hours for tonight. We're going to be talking about discrete probability distributions. Let me do a quick check just to make sure that my blue snowball is working. Move it over here a little bit closer to me. It'll take me just a second. For some reason, I have that opening screen. And by the way, I work with an older... Lord have mercy. We have a little bit of feedback. Sorry about that. But I'm so professional, I just use my phone to check. But I have an opening screen that lets you know that we're starting in a minute. I notice flaws with that. It counts down starting from 5. Gets done with a minute and starts over from 5 again. I got to figure that out. It got a flaw or something in my stream. And then I go to a transition, which I really like my transition. I spent a lot of time on it. And it transitions just a quick right into here, lets you know it's online office hours. And it just goes black screen. So I haven't quite figured that out. But anyway, a follow-on from last night's statistics class, we talked about permutations, combinations. And tonight, what I want to do on here is I would like to work some problems. I told you last night I would come on and work some problems from discrete probability distributions and put some of that combination work within what we're doing. Now we're going to take the rules of discrete probability distributions and work with those. We're going to work with basically sets of data, and then we're going to find the mean of these probability distributions and the variance and the standard deviation, which is just the relationship with the variance, as we talked about quite a bit in class. So let me go ahead. If you're from my class, just let me know. Let me know who you are. I always jot it down. I always put it in my grade book. It doesn't always go in as an extra grade. Tonight's just an extra video on demand for folks. If you want to stop by for the stream and ask questions, it's always welcome. So let me just do one quick, before I transition the screen here, let me just make sure that Stream Deck the other night started going out on me. What a nifty little expensive tool that I've had for years. Finally start putting it to work and it goes bonkers. So let me do this. Back to stats. And here we go. Okay, very happy with my little stream, very happy with Keynote that I've started using. It does eat up a little bit of resources considering that I also used Discrete from the iPad to come over. So I'm just going to pull my stuff over for a second. Looks like we got severe storms, severe thunderstorm watch tonight until 11 here in eastern North Carolina. So let me pull my iPad over so we can get started here. I can still reach my mouse pad. Quite the endeavor. When I watch people streaming online or streaming games or whatever, they have a super duper setup. Everything's within reach. Mine is like a very neat desk, but kind of cluttered. I'm still trying to get everything together. Probably need a larger desk. I don't know, but I like this one. Let me find my mouse. Okay, and then I need this back over here. Look at that. So here we go. So what I put up here is exactly what we talked about last night. And I put this in your notes last night. We went through a few problems. We even worked through the calculator with, we even went through the calculator with working with these right here, right? So finding the variance in the standard, I don't know that I did standard deviation, but again, the relationship is there. You just take the square root of whatever the variance is and you're good. I got stuff popping off here at different time intervals, so I apologize if the stream takes a second for everything to catch up. I would say it's a function of this 2015 iMac that I've got, which is a fantastic system, just a little bit slower. Hey Artemisia, thanks for stopping by. I appreciate it on this Thursday evening when we got thunderstorms rolling in here. So again, we broke down the mean in terms of calculator talk and we put it in the TI. I'm going to do that again tonight at the end of this. And remember, this is a video on demand. Certainly it's a stream. And if students of mine stop by and stick around and watch this or interact, great. I appreciate it. If you stick around just for a second or say hi and then wait for the video on demand, that's fine too. No issue. There's certainly no accountability for this. This is just office hours. Just something that I enjoy doing And I'm hoping that my students take a little bit of something, even if they take just a little bit away, it makes me happy that they're gaining in the classroom. So here we go. Okay, I made it blue because that just seems to show up a little bit better here. All right, so discrete probability distribution up there in the upper left-hand corner lists each possible value the random variable can assume. And remember, we talked last night about what discrete meant generally. We talked about it in detail, and we talked about it very generally so you can kind of get an idea about it. If you can count the items, number of chairs in a room, number of students in the room, number of eggs in a carton, it's typically discrete. You can have 12 of those. Even though they are different sizes, we count them the same. You can't have a half of a human being, even though they're shorter than another one, or taller. You can't have double a human being, so you just have 1, 2, 3, 4, 5. They're countable. Whereas continuous, which we haven't gotten into yet, we'll jump into that following, not tonight, but following when we finish all of this material with discrete probability distribution. And we'll talk about normal curves in a whole lot of detail. We've already started that with follow-ons with the empirical rule. Okay. Sorry, too much ice. Several constraints that we have to follow when working with probability distributions. In other words, and it's no different than stuff we've dealt with before. The summation of all the probabilities in the table have to equal 1. Just like in the sample space, just like the other piece of the tree diagram in each individual instance of an event or each outcome. And then the individual probabilities for each value of the random variable has to fall between 0 and 1. In other words, probabilities, we've dealt with that already too, the range of probabilities rule. All probabilities fall between 0 and 1. All right. Let's move on. We'll come back to these because I've got these embedded within this presentation. So I got to jump out of it with Doceri. I'm trying to find a replacement for Doceri because it is quite a resource hog as well. Yeah, why would it move forward? So let me go up here, click there. There we go. Okay. And again, I've got up in the corner what a discrete probability distribution is, and then I've got a distribution sitting right here in front of me. Hasn't come to you yet because I'm looking at the stream on both YouTube and Twitch. But I do have it here. I don't know how far behind. I'm just going to pause for just a second. Hey guys, appreciate you stopping by. I really do. And Adam, how on earth did you get here? I love it. I appreciate it. Yep. Yeah, thanks for stopping by. I do this for my class, and if anybody stops by and says hello, I just appreciate it. And I thank you guys for coming by. I have an old Mac that I stream from, so I have to pause every once in a while and watch everything as it catches up. I am not a pro streamer by any stretch of the means. So, okay. I still don't have it up here yet. Let me troubleshoot a little bit. But yeah, guys, appreciate you stopping by. And now I'm troubleshooting. I cannot figure out why. Now it's up there. Good gravy. And I see not the ring of death from 360, Xbox 360, but a circle of death sitting there going back and forth. Okay, maybe. I got a maybe. When I'm looking at Twitch finally caught up. Okay. Frustrating. Now I'm back to where I want to be, and hopefully it'll go here. I'm going to press forward with this and just hope that it pushes out to the stream. Please let me know if I'm talking about some table of values that I've got here and you're not seeing it on your end. I do see it on YouTube. Twitch just caught up too. Yay. We're finally there. So thunderstorms coming in this area in eastern North Carolina, so I'm sure as I press on, that'll probably be my next dilemma. But what more fun can we have on a Thursday night? All right. So I put up there in the corner just the rules, just copied and pasted just so we have them for reference. You can always take a look at those. But let's take a look at this particular probability distribution. Remember, we built these in class last night. We actually constructed them from data that we had, and we pushed these together. You've got values. One second. You've got values for the random variable x. Change the color. There we go. You have values for the random variable x right there. So x can take on the value of 0, 1, 2, 3, or 4 in this particular problem. Now, we have no context for it. This is just a table. And then when you look across the bottom, the probability of randomly selecting one instance of whatever we're doing, selecting one household that has 0 televisions, we were talking about that last night, would equal 0.07. The probability of randomly choosing, back to our context from last night, a random household from a certain population that we've gathered data from. So we select one household, and the probability of those guys having one television is 0.20. Now, that's not what this data is. I'm just reflecting back to give it a little bit of color. And then so on and so forth. So you go all the way to the end of the probability of 4 televisions equals 0.13. But notice here, we don't know what that is. So the probability of randomly selecting a household in this population and there being 3 televisions in that household, we don't know what it is. But it's not in the table, but I think we know what it is, because if you remember, if you look up here at the rules, okay, thunderstorm watch, so that's not too bad. If you look up here at the rules, we have to follow these 2 constraints, right? Each of the probabilities, range of probabilities rule, has to fall between 0 and 1, right? And the sum of the probabilities have to equal 1. Because of this, we can work with that missing value, right? So it's just an algebraic thing. We know that the sum of the probabilities should equal 1. So if I take 0.07 plus 0.20 plus 0.38 plus 0.13 and add those up, well, I don't know what they are off the top. I don't remember, so let me add them up. 0.07 plus 0.20 plus 0.38, I think that was the other one. Yep, plus 0.13 equals 0.78. So our total of the numbers that we can see is 0.78. We know these have to equal 1. Therefore, I take 1, subtract 0.78, and what is that? 8898.22. So I know that my value in here is 0.22. And I know that because of the rules and the constraints that I have on this probability distribution that I have to follow. So 0.22 is what we were looking for there. So if you have one missing value in a discrete probability distribution, you can find it. Yes, thank you. Beautiful. 0.22. Not too bad. Sorry, if I missed something in chat, it's because I'm kind of looking back and forth, and I am not a, I try to be, I've taught this for 20 years at the college, but I've not streamed it for 20 years, so I get lost in the pieces. All right, so there's that. So let me rewrite that. I took it out. 0.22. Now let's expand this a little bit. We have a probability distribution, and now let's find the mean, shall we? And let me switch to, let me see if my Stream Deck will work. No, why would it? Okay. I'm switching to another screen that looks just like this one, except we got a calculator in there because I want to move to the calculator, but not to make it easier. There we go. Thanks, Hola. I got some folks coming in from Twitch too, just to engage for a second. Thanks so much for watching some of my gameplay. I play games on Xbox and PlayStation. I shouldn't tell people that because it's like I'm a 14-year-old instead of whatever how old I am. But it's a lot of fun. So let's take a look at this. And what I want to do now is I want to find the mean of this probability distribution. So the mean is equal to, and I love the ghost of the calculator in the background because I'm just going to change it in a minute where we can see it. But for right now, it's just kind of sitting back there. I hope it's not too distracting. So I'm going to go the summation of the x values times the probability of x, right? They're in this table. So here's what that looks like. Let me try this. Let me switch to like a peach color so I can differentiate a little bit. So what we've got here, we're looking at the summation of the x value times its probability plus the x value times its probability plus the x value times probability, and we're going to walk through that. So we've got 0 times 0.07. Well, that's very easy, isn't it? I've got 1. I'll switch my parentheses up. Hope that doesn't confuse you. Now I've got 2 pairs. But 1 times 0.20 plus 2 times 0.38 plus 3 times 0.22, and I've run out of room, so I'm just going to extend it to the bottom, plus 4 times 0.13. All I got to do is find these, right? So I just go, this first one, very easy. This becomes 0. This becomes 0.20. 0.38 and 0.38, that's 60 plus 16, 76, right? A little deconstruction. And 3 times 22, 20, 40, 66, so 0.66. And then down here, 4 times 0.13 is 2 times 28, which is 40, and another 16, which is 56. Okay, so there's my values. So I'm taking the summation of those values, right? So I need to add them all up. So basically what I've got down here is 0 plus 0.20 plus 0.76 plus 0.66 plus 0.56. The reason I'm adding them up to find the mean. So I was about to say something way off the charts. It's not. So I'm going to go 0.20 plus 0.76 plus 0.66 plus 0.56, and I get 2.18. Hopefully you can see that at the bottom. So 2.18 is my mean. That's the mean of this discrete probability distribution. So 2.18, as I was showing last night, 2.18 is, if you're looking on a horizontal scale on here, is about right here. So that mean actually pulls more towards 4 than it does 0. Does that make sense? I think it does, because the 22 would outweigh the 20, the 13 would outweigh the 0.07, and the 0.38 would also pull it that direction as well. So you're going to pull towards the middle to start with, and then the 0.22 being greater than 0.20, 0.13 greater than 0.07, logically it's going to pull that mean out there. It's got more weight on that 4 end. So 2.18 logically makes sense. And remember, I told you in my class, we can work through computation and get a number all day long. But when you put it in context with the graphical representation or the graph itself or the tabular or what have you, you should be able to logically make sense of it, justify and defend your position on why 2.18 seems to be the right answer here. So I feel pretty good with that. And I know my students have seen me in class make computational errors very quickly where I don't transcribe a 2 down or I don't bring something down. But once we get to the end, hopefully they've also taken away that they see me work backwards back through the problems to see, because logically the answer doesn't make sense because I didn't square something along the way, or I didn't sum something, or I just transcribed the numbers wrong. Okay, so we found the mean. It's 2.18. 2.18, 2.18, 2.18. Let me remember. All right, 2.18. No problem. Now I want to find the variance. And the variance equals the summation of the x values minus the mean squared times those probabilities. A little more complex, but not horribly so. And again, we transcribe this to the calculator, which I'm also going to do with this problem here in just a second. And again, let me just say, I really appreciate folks stopping by. I truly do. I do this for my class for online office hours. I also do it for myself because I just enjoy doing it. Kind of walking through it and going back through stuff, putting these keynotes together and everything. It just keeps me grounded within the statistics class. Okay. Let's find this variance. And I'm sorry I keep taking a swig of Mountain Dew. ice goes in my mouth and I have to chew it. That's surely distracting. So we're doing the same thing. We're still finding the summation of some stuff. So let me just go down here on the bottom and write it out. So I'm going to take the first x value, subtract the mean, square it, multiply it times the probability that goes along with that x, with that value for the random variable x. So I've got, basically it looks like this: 0 subtract 2.18 squared times 0.07 plus 1 subtract 2.18 squared times 0.20 plus dot dot dot. Remember we did this early on. Now we don't have too many numbers here, but I just have a limited amount of room. If you had a nice piece of paper and you wrote a lot neater than I did, you'd be okay. So now I'm just going to go all the way to the end. So then we get to the end and we are at 4 subtract 2.18 squared times 0.13, and everything in between as we got there. Then we're going to take the sum of this, right? So we take 0 subtract 2.18, that's minus 2.18. We square it, multiply it times 0.07. There's our first number, plus, and so on and so forth. So I can't say that enough, but I want to do this particular one a little bit differently. So what I'm going to do is I'm going to pull all this off, and I'm going to go back to how we use the calculator and the cell sheets in the calculator to work this one. So let me find my mouse first. This is great. There it is. Okay. I got 3 screens, so if you see me looking up, I've got some stuff up on the screen. Nothing major, but it's just a way of me to keep up with stuff during the stream. All right. Look at that. Okay. TI-84 graphing calculator. And what I'm going to do is since I've got stuff behind here, I am going to write over here that the mean is 2.18 because I need that in my computation for the variance. And then I'm going to write the formula for variance, and because we're going to transcribe that to the calculator in terms of the syntax. Fix that a little bit. There we go. Equals the summation of the x value subtract the mean squared times the probability of x. Okay, no problem. In the calculator, I'm going to go to Stat, Enter, and I'm going to scroll up here. I'm going to hit Clear and Enter to get rid of the stuff that's in there because I don't want that. I want my table in there. So I'm going to go 0, Enter, 1, Enter, 2, Enter, 3, Enter, 4, Enter. Scroll up. Oops, not up. Then I'm going to put 0.07, Enter, 0.2, Enter, 0.38, Enter, 0.22, Enter, and 0.13. I wish I could get this. The screen itself is too bright against that camera, and it drives me nuts. And I have tried to minimize the glare on it, and I just can't seem to do it. So hopefully this is showing up okay. All right. Now I'm going to scroll to this third column and scroll all the way up to L3 because I'm going to put the formula for the variance in L3 at the very top, and it's going to fill in all those values that we were trying to find individually in the table itself. I got to know what the syntax looks like, and my class last night did a very good job of walking through this. Look at this mess. Time out. I got my big head. Hold on. 2.18. Hopefully we can see that, and then we'll go to this. Oops. Okay, even though it's funky writing, it shows up a little bit better when my big head isn't in the way up. So let's look at the formula right here for variance that we worked with, derived in class last night. Let's look at this. We're just doing computation tonight, so let's look at this. So this one. I want to put this in terms of the syntax of the calculator. So I'm up at the top in L3. Like I said, I'm going to put the formula there. It's going to fill in below, and then I'm going to take the sum of those numbers below, and that'll be the variance. So my x values, instead of it being x, that's going to be the values, excuse me, in L1. The mean we already know, it's 2.18. If we didn't know it, we could put a formula for the mean in there as well. And I go squared, and then I multiply by L2 because the probabilities are in L2 in my calculator. Okay, that's all I'm gonna do. So I'm up there already, so I'm gonna go second 1 for L1. Actually clear, I need parentheses. Second L1, subtract 2.18 squared. There's the first part. And then I'm going to multiply by L2. So I just put a parentheses, second L2. That's it. When I hit enter, it's going to fill in all the values that we were finding individually below. Poof. So there it is. So I've got the individual values. In other words, 0 subtract 2.18 squared times 0.07 is that number in the first block that's highlighted and so on. I have to exit out of here. So I hit second, quit, because I want to go to second stat, scroll over to math, and find the sum. Now we had such few numbers, I could just write them down and find them individually. It's not a problem. But I'm just going to show you in here because you might have larger sets at some point. So it looks like the variance is 1.202. And there we go. If I wanted to find the standard deviation, I would just simply find the square root of that. So the standard, I don't know if that shows up. That's not showing up. The standard deviation would just be the square root of 1.202. I'll leave it at that because I'm kind of out of room with everything that I've got on the screen. So there we go. Any questions? Any of my folks from class here? We had a good turnout the other night from class. Tonight, Artemisia I saw was up here a few minutes ago. And then I had some folks from other places, and I appreciate you being here. Okay. What I want to do next is I want to go back to stat, edit. I'm going to clear out these values, whoops, and I'm going to put my formula for the mean in here because I want to test to make sure that the computations that I worked out individually and took the sum of get me to 2.18. So let's just see. So in my formula for mean, remember it is summation of the x's times the probability of the x's. In terms of the calculator, basically I'm looking at the summation of the L1s times the L2s, right? Very easy on that point. So I go second L1 times second L2. Up there at the top of L3, I hit enter. It fills in. Then I add these together. They look very familiar. I think we did these by hand, and that's what we got. So let's exit out of here. Second mode, which quits. Second function of that button. Second function of stat. Scroll down to sum. Take the sum of L3. Oh, that says 2.14. I'm slightly off somewhere. Maybe I rounded something. I don't think I did, but maybe I did. Oops. 02.76.66.52. Or maybe I made an error. When I go back and watch this when I'm done, I may have made a slight error, but I was pretty close, but I was just off by decimal, by a hundredth of a decimal point. Okay, I'll take that. I'll take that hit. And if I was a good student in class, I would have shown all my work so that instead of marking me wrong, my professor would have looked at it and not marked it wrong, but seen my work and gave me partial credit, maybe only marked off 1 for some flaw that I had within my computations. Okay. All right, enough said. So let me turn that off. Let me find the mouse again. So we got through that one, so I think I deserve. All right, and now I'm going to take this calculator down so we don't see it, and we'll go to the next slide. So certainly this is maybe a 25% professional stream. I have to do things by hand. That's okay. I don't mind. All right. So now I need to go up. I need to turn Doceri off. I'll walk you through everything I do. Punish you for being here. I go up to the stream up here, or up to the keynote, then I push it out to the next one. I've got my next problem, which hasn't updated yet. It has updated on my end, not here and not there. So I'll just start talking about it. Basically what I've got here is I've got another problem, and we have to figure out what the missing value is, and then I want to find, there it is, and then I want to find what the mean is, what the variance is, and what the standard deviation is. Okay, so let's find the missing value. So from before, I know that, first of all, the probabilities all have to be between 0 and 1. 0.05, question mark, we don't know yet, 0.23, 0.21, 0.17, 0.11, 0.08. They all fit our range of probabilities rule. So we are good with probabilities, no problem with that at all. But I want to find this, because if I add up all the numbers that I've got and subtract from 1, then that will leave me with what's missing. It's just basically an algebraic manipulation at that point. So I'm going to go 0.05 plus, actually you could just put an X there for that, plus 0.23 if I want to be more exact, more mathematical, plus 0.08. I think I got it all in, yeah, just barely. So I get my calculator here and I go 0.05, I got a nickel, plus 23 cents, plus 21 cents, plus 17 cents, plus 11 cents, plus 0.08. Part of my flaw in that previous problem, to be honest with you, either I wrote it wrong, or the angle I'm looking at my calculator here with the way I've got the screen turned down. Of course, I've got excuses, but I could make it easily mistake a number for another one. So I've got 0.85. So that equals 0.85 time out. Yeah, more algebraic. X plus 0.85 equals 1. So 85 is the sum of all those numbers that we have. Artemisia, was that in the previous problem? Is that where I made the mistake maybe? That's not a mistake. The 0.20, 0.2 are the same. But I may have looked at them wrong in all honesty. I may even have put a 0.22 or something. But thanks for helping me troubleshoot that. I think you're talking about the previous one. So I've got x plus 0.85 equals 1. X equals 1, subtract 0.85 just to keep it in the algebraic family. So x equals 95, so you're looking at 0.15. The x value in this case is our question mark. And so this would be 0.15 right there. The sum of all those equals 1. And just like I mentioned in class last night, when you add these up, depending on how you took the original numbers, you may have rounded in a certain manner. You may have rounded differently than me, so I may get a sum that is 1.001, which I think we did last night in class. or I may get one that's 0.9998. That's as good as 1, considering you've got to understand where you came from with the numbers. You know, did you round, and to what extent did you round? Okay, so there we go. X equals 0.15. So I know that, no problem. So now, and we have no context. Again, this is computational night. I'm just going through some problems that we will see in class. We talked more theoretically and about the vocabulary and symbolism last night in class. So now let me find, write this. So I know that the mean of this particular probability distribution is equal to the summation of the x's times the probability of x, which again I'm going to write out. I'm going to start it here. I'm going to write it out, and then we'll go to the calculator, double check, make sure I've got it right here. So I've got 0 times 0.05 plus 1 times 0.15 plus 2 times 0.23 plus 3 times 0.21 plus 4 times 0.17 plus 5 times 0.11 plus 6 times 0.08, and that's the last one. 0, 8, 11, 17, 21, 23, 5. Okay, I think it's right. So now this first one, very easy. That's a 0. This is easy. It's a 0.15. 2 times 23 is 40.46. 3 times 2, 463. Classroom kind of numbers, not too hard. 4 times 0.17, well that's 2 times 34. 0.68. 0.55. And 6 times 8 cents is 3 times 16 cents. 16 is 32. 48, isn't it? Now I add these all up. So let me go 0.15 plus 0.46 plus 0.63 plus 0.68 plus 0.55 plus 0.48 equals 2.95. The 2.95 should be our mean. So let's see where that falls. 2.95 is almost, well, that's not good. It's actually probably here, isn't it? That would be our 2.95. Let's take a look at that in context of the numbers in the table. Okay. On either end, the 0.08 is larger than the 0.05. It's going to pull it that way. 0.11 and 0.15 is going to pull back the other way. 0.17, 0.23 back the other way. 0.21 and 23. 2.95. Yeah, that makes sense because we're on that side of the 3. 3 is, if you look at this from a median standpoint, you got this, 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 and this. So there's your median, right? Right smack in the middle. So as a measure of center, that's right smack in the middle. 2.95 is slightly less than that because it's being pulled, the mean is being pulled back the other direction by these numbers here. And now this one is less, but only by a smidgen, and that's the outer number. This one is more, this one is more, so there's why it's being pulled back and pulled back just slightly. So as I look at this logically, that 2.95 makes sense, okay? It makes sense to me, so I feel good about it. Oops. All right, so there it is. Now, I'm gonna write it right up here, 0.2. No. 2.95. There's our mean. Now I want to go back to the calculator real quick, and I'll work through these a little bit quicker. Oh, dude. I gotta get me a new Mac. Okay, so let me bring that calculator so you can see it in the screen. Okay. Yay. I'm going to go to Stat, Edit. I'm going to go up to the top, Clear, Enter. Up to the top, Clear, Enter. Up to the top, Clear, Enter. I'm going to enter my numbers in real quick here, 0 through 6. So 0, 1, 2, 3, 4, 5, 6. Scroll over. A nickel, 0.5, 0.15, 0.23, 0.21, 0.17, 0.11, 0.08. Boom. Okay, so I got my numbers in there. Scroll up to the L3. Remember that, in fact, I'm going to take, with the exception of that number that represents the mean, I'm going to take that out. And remember that the mean is simply summation of the x values times the probability of x, which in terms of the calculator is going to be L1 times L2. Okay, so I'm going to go second L1 times second L2. There it is. Boom. Now I need to add these up. They look like the same numbers I got. Maybe I was off on some, but I don't think I was. Second quit, second stat, scroll over to math, down to sum of L3, 2.95. Yay. Not a hard problem really in terms of numbers, but I'm glad that this time it ended up being the same. Okay. Now we've got the mean, and I will write it right over here. I'm just going to put mean equals 2.95. I verified it. I feel good about it. Now I'm going to find the variance. Okay, and the variance is the summation of the x values, subtract the mean squared times the probabilities. Okay, I'm not going to write all of those out. I'm just going to go, I'm going to transfer this straight to the calculator this time. Whoops. Scroll up, clear, enter, and scroll up. I'm going to put my formula in there, but my formula this time is going to look a little bit different. I don't know why this isn't showing up yet. Sorry about that. It's showing up on my end, my formula. Anyway, I'm going to transfer it down. Then when I put it in, if you have any questions, just say, please do that again, because something just isn't transferring on my screen here. Let me get, I don't know if any of you who are in this live have ever used Ecamm. I use Ecamm with my Mac. You know, when I go to preview mode, something's missing. Daggone it. It's fine. I'm going to keep rolling. I see on my stream for YouTube it's kind of spinning, but there it's back. Okay, anyway, back to the syntax here. So I'm going to write down here, and I'll change the color to like a dark green this time. But I am looking at the summation of the x values. The x values are L, that's not going to work. I feel like light green. The x values are going to be L1. I'm going to subtract the mean and square it, and then times L2. So that's what I'm going to put up there. Boy, I apologize if this stream is kicking out and kicking in. I truly do. I'm kind of viewing it on my phones down there. It seems to be, but I'm just going to press forward and hopefully it's still going. So I go parenthesis, second L1, subtract, and our mean was 2.95, square it, times second L2. Hit enter and it fills in. When it fills in down below, I'm just going to take the sum of those, and that sum is going to give me the variance. So I go second quit, second stat, scroll over to math, oops, scroll down to sum, second L3, and I get 2.6075. So I get 2.6075, and that is my variance. Hey Rohit, I hope I said that okay, Mr. Kumar. Or Miss Kumar, I'm not sure, but I think I'm pronouncing it Rohit. But thanks for stopping by, I appreciate it. Hopefully this stream is still going. I'm telling you, I've got my YouTube and my Twitch down here, and they both seem to be just kind of stuck. But I see on my preview screen everything looks okay, so hopefully everything's still okay. Artemis, if you're still around, if you just let me know yes or no, or anybody that's still on here, just let me know yes or no if it's still going. But what we've done tonight so far, and I don't know how much more time I'm going to spend. I've spent about, I don't even know how much time I've spent. I usually have it up there. About 45 minutes. That's usually about how long I go. But I've spent some time on these discrete probability distributions, finding the missing values, understanding the constraints that we have on it, range of probabilities, each individual probability for every value that the random variable in the discrete distribution can take has to fall between 0 and 1. Range of probabilities rule, should be nothing new there for my students anyway. And then the sum of the probabilities in that distribution, just like with our sample space, has to equal 1. So we are able to find the one missing value, given that we add them all up and solve for that missing value, which is just 1 subtract whatever we get with the sum of the other values. We've done that twice. And then I work through finding the mean of these probability distributions, looking at them with respect to the table, right? And then finding the variance. And of course, I found the standard deviation. If I want to find the standard deviation of this, the relationship is the same between variance and standard deviation. You just take the square root of 2.6075. That'll be your standard deviation. So hopefully this has been okay for you tonight. I've enjoyed the fire out of it. I always do. And now I see that my streams seem to have caught up. So hopefully they were okay for you the whole time. But I appreciate everybody that stopped by tonight. I had a pretty good crew. Like at one point I looked up, I just glanced up, there were 9 people in this stream. 9 people watching me work through some probability distributions. Makes my heart grow on a Thursday night. So I appreciate you. But I typically come on Tuesdays and Thursdays. I do these online office hours for my statistics course and any other courses that I'm teaching. I'll put material out here, but right now it's just all statistics. And it's just a basic analysis course, and we'll walk through items just like this to try to help my folks in class and give them an opportunity to ask questions if they need to. One thing with this eCam software is I can bring folks in here to talk. I have a screen. I hesitate to push the button to get to it because I'm afraid it'll lock up tonight. I seem to be low on resources. But I take to the screen. I can bring people in there, whether they want to show their faces or just some other picture is fine, but we can talk through it. I find that to be even more beneficial with this. And if anybody from the web is in a stats class or wants to know anything about calculators, I've been putting together calculator videos for my YouTube channel. I've only got a certain distance because I do have a day job and sometimes I run out of time. So if you have any requests, just send me an email or leave a comment. And again, thank you all for being here tonight, and I appreciate it. Artemisia, I will see you next week. If you have any questions, send me an email. And with that, I'm going to go ahead and sign off. So thanks again. Appreciate it. Why is this thing doing this? It's locked up. Okay, what am I going to do? I'll do keynote off of here. Sarah.